Hello there, this is Toby, and welcome back to the LLVM tutorial walkthrough series. We're at the beginning of chapter 5, and the last video we finished up chapter 4, and we have a working JIT compiler, which is honestly pretty amazing. Let me show it off. So my program is called mylang.cc. Also, to prep for this, I have their code for chapter 5 compiling successfully. So if I run into trouble, I have their code to refer to, which I know already works. Okay, let me run the code as it was finished at the end of chapter 4 to show you where we are at. So we have this repo prompt, and we can type in some code in the Kaleidoscope language, and it will basically parse this code, generate equivalent code in terms of LLVM IR, which looks like that. It prints that out to you. That's the code in LLVM IR. It compiles that down to machine code. The machine code then is stored into the memory, into some memory buffer within the executable, and then that memory buffer of instructions is executed, and it returns to you this C function, which when you call it, it'll actually go through those instructions and execute them, and the result of the execution gets printed out in this repo like this. So that's what we have. Let's start chapter 5. Okay, so chapter 5 is about if statements and for loops. So control structures, which is actually really interesting. So currently we have no control flow structure. That's what we're going to add in this chapter. So let's start with the if then else. So an if statement in Kaleidoscope looks like this. Again, this kind of looks like Ruby, I would say. Yeah, it looks like Ruby. The whole language is very Ruby/Python like. So that makes sense. I guess first step is we need to extend the lexer and the parser to be able to parse the if statement. So let's go ahead and do that. First, we need the tokens that represent the if keyword, the then keyword, and the else keyword. So let's go ahead and put those in. So our lexer is at around the top of the file. So I'll just copy these in. I won't bother typing them all out because this is very straightforward, and I wouldn't be learning that much by typing it all out. Now we need to recognize the new keywords in the lecture. This is actually easy because we already have example of how to do that. So this get toke function is responsible for yeah, let me show you a visual, just in case you're joining us late and haven't followed every one of the previous episodes. So let's say your string is IF space and less than 5. Get toke is responsible for reading character by character, and when it sees a token as a group, it'll return that thing as a token. So it'll first read it's an I. So I is a alphabet character. Because of that, I want to try to grab more characters, so it'll advance this arrow to the next one and so forth. And then it'll say, oh, there's another alphabet character. I'll put it into the group, and then it will advance the arrow, and then, oh, it's a space, so space should delimit a word, so that this stops it. So it'll group these two guys as a token. So this is a token now. And previously, this would have been recognized as an identifier token because it was not put in the list of keywords. We had the def keyword and the extern keyword. And the keywords are recognized pretty simply by adding one of these if statements. So because all we're doing here is adding keywords, we can just add one of these if statements for each keyword. So let's go ahead and do that. So we just have if, not ID, if then, and else. And in the case of if, we're gonna say that, well, this token is of type toke if. Yeah, that one. And if the word we found was then, it's a token if then, toke then, sorry. And if the word we found was else, then the token is called toke else. So we're done with this part. And yep, and that's exactly what the tutorial asked me to type. By the way, when you're working through a tutorial, try to think at a higher level. So I decided to do, because I thought that I pretty much knew what I was doing for this case. I decided to, instead of refer to the, instead of copying the example code character by character, I decided to just do it myself without looking at it. If you feel up to doing that, then by all means, you should try that. And I'm not talking about just this tutorial, just tutorials in general. Okay. AST extensions for if then else. Yeah, so now we need AST nodes for the if expression. We don't have an else expression or a then expression because the then and else are just part of the if expression. So what we have is, I'm gonna refer to this code this time and type it in. So we're gonna go to the section of code where I have these, oh, I don't know why I decided to indent that like that. Actually, I know why, but it's fine. Okay, so so this is the section where I define the classes for the various AST node types that we have. So I'm gonna add a new one. I will add it actually, should I add it near the bottom or near the top? I'll do it near the bottom or at the bottom, which is after the function. I have all these blank lines. I'm gonna remove them. I'll do it here. Yes, I will do it here. Okay, so I'm gonna add a new class called Ifthenelse, which is an AST node that represents the if statement. And again, we're gonna use the unique pointer, which is a managed pointer, I think. I don't know if it's totally managed. It's called a smart pointer in C++ parlance. Okay, this is gonna be, so this basically we have three variables. Each one has the same type. I'm gonna list them and line them up with each other. So we have a then, a cond, which is a condition, a then and an else. And then we're gonna have this initializer list. This move thing is necessary in order to move when it's passed into this object. When a constructor of this if expr AST object is created, these unique pointers are passed in, and we actually want to move the ownership of these three things into the object, as in my if expert AST object owns these 3 pointers now. Again, I'm going to line them up with each other. Okay, like that. And then we need the body of the constructor, which is going to be empty, and they have it over here. And again, we're going to need to write the code gen for it, but we're going to do that later because we need to this is saying we're going to override the base class's definition of codegen, but the base class has no real definition of codegen. The base class has a virtual definition of codegen. I actually will show that. Yeah, when you set the implementation of a method to 0 in C++, that means this is a virtual method. It's really bizarre. That's how it works, as documented by all the tutorials that I've found. Okay, now let's write the parser for the if statement, or the if expression. So where should I write that? I guess there are all these parse functions here. Are they functions or are they methods? They're functions. Yes, we don't actually have a parser class. Come to think of it, that's a little surprising, but that's cool. We just have a bunch of functions that parse the input. So yeah. Unique pointer expr AST parse if expr. So again, if you haven't been following along in the previous episodes, we have a parse function for each concept in the language, each syntactic element in the language. So there's parse primary, which a primary is like either an identifier or number or a thing in parent. It's like an unary expression, an expression that just has one thing in it. And we have parse identifier or call expression, parse paren expression, etc., etc., etc. We're going to add a parse function for if expressions. So first we're going to get next token, which eats the if. So the way this works is whoever is calling the parse if expression, they have already detected that the current token is the if statement. And then when it sees that the current token is the if keyword, it dispatches this function. It will once we're done writing all of the code that needs to be written. So this get next token just advances the pointer. So like it's like, oh, we have this token called if. Okay, so let me advance the pointer so that we're looking at the next thing, whatever that thing is. And then after the if statement, there should be an expression, because it's like if n greater than 1. And the n greater than 1 would be the expression that we're gonna defer to the parse expression function to parse that, and then we'll check whether that succeeded or not. So it's like, did you parse a condition here? If it didn't work, I'm gonna return null pointer, and in this parser, a null pointer is a signal that it didn't work. So yeah, it didn't work. Although it doesn't totally stop the world either. It's a little ambiguous actually. So sometimes we log an error like this. Sometimes we don't. Oh, but I guess even in cases where we log an error, we still return a null pointer. So returning null just means parsing this thing did not work, whatever that thing is. Okay, so now we're gonna say, okay, we parsed, so an if statement again in this language is like if n is greater than 2, although I don't think the greater than sign is part of the language at the moment. So it's like if n is less than 2, then we're gonna say n times 2, else maybe n minus 2. I don't know. Maybe that's the if statement. So we're saying, hey, we were looking at the if statement. Now we're gonna advance the pointer and have parse expression parse this n less than 2 part. Parse expression is gonna parse this part is, if it was successful, is gonna end up being that condition that's returned. So then now the cursor is over here, and then we're gonna say, okay, well actually the cursor should be over here, and then we'll say, hey, are we looking at the then token now? We should be, if it's a valid if statement. If it's not, then if it's not a then token, we actually don't really know what to do. So it's gonna print a error. It's gonna log an error. So that's what this code does. I decided to do it a little differently from the way the tutorial does it. The tutorial has a variety of log error functions, which return a variety of different types of things, but in reality, all of those functions return null. And so instead of doing that, I didn't want to bother writing a variety of log error functions. So I just have one log error function. Then after calling the log error function, I'm just going to manually return null pointer. This way, I don't have to have a variety of log error functions, and that's what I prefer. Okay, so this eats the then. Okay, so now it's gonna parse the part after the then now. So see, it ate the then keyword, eat the then. After eating this then keyword, then is gonna advance the pointer to this n token, and we're gonna call this parse expression one more time and expect it to parse this expression and say this expression is what represents the then. This expression is what represents the then. This one is the cond. We'll have the cond and then the then, and then later on we'll have the else. So this guy is the cond, this guy is the then, and this guy is going to be the else. And those are the three parts of a if expression node, as we saw when we were creating that if expression AST class. Now if it was not successful in parsing the then part, then again return a null pointer. It didn't work. And again, we're expecting an else here. So if we're not looking at an else after parsing the expression for then that didn't work. We'll print expected else, and then we'll return null pointer. Now we'll do get next token. This eats the else. Why does that still say eat then? Eat the else. They didn't put in a comment saying eat the else, but I know what they meant. So now we're gonna auto. Auto is like var in some languages, but it allows you to not have to explicitly write out the name of the class. I mean the name of the type of this variable. infer it. It'll let the compiler infer it, because compilers nowadays are pretty smart. Even C++. Oh! Okay. So now we're successful in parsing all three parts, the con, the then, and the else. We're gonna put them together and say, hey, now we can have an if expr AST. And if you're confused by this make unique, just think of it as newing up an instance of this class, except you point to it using a unique pointer, which is called a smart pointer. Okay, so there we have it. Oh, actually, one thing I want to tell you about, I made an enhancement to my website this past week, which is that the videos, if you click on a video link on my website, for most of the videos that I have put out, it now has this page which shows you the transcript, the text transcript of the video. So you could skim through the text if you want, and you can click on one of these time markers to jump to a particular location in the video if you want to. So hopefully this will help some of you who are interested in this material, but feel like there's too much material to go through. You can sort of look for and skip to the parts or the episodes that you're interested in. I think there is one episode where I talk about smart pointers. Maybe I don't remember which one. Okay. So now we have a function that can parse if expressions now, I think. But we have to dispatch to it. So we're gonna go to the parse primary function, which I saw already, and add a dispatch for the parse if expr, which it kind of looks like this, like case is an if token, right? I'll just add it to the top here. Case we're looking at the if token, then we want to dispatch the parse if expr to parse an if statement, which is what they did. They put it at the bottom, I put it at the top. It should work either way. Okay, so now we have a parser. I wonder if it compiles. So, something I've changed actually offline is that I changed my build script to take a command line argument instead of hard coding the name of the file that I'm going to compile. So it references the command line argument. This is bash, by the way, and I'm sorry if you're not on a Unix system, this is not gonna work out for you if you're on like Windows. So I'm sorry about that. I might try all of this, compiling all of this code on Windows at some point, and if I do, I will share that as well. But anyway, this is for Unix, and this is how you reference a parameter, and then this is how you substitute the file extension. So this substitutes the CC file extension of the file with a .bin extension. So now the way I use my build script is I call build and then the name of my file, and then it'll build a binary with the prefix of my file .bin. So it's going to generate a mylang.bin. Well, if it works, which it didn't. Let me fix this first problem. 3. I'm not sure if I can get everything to compile at this point. Oh, it's saying use of undeclared identifier parse if. So it's saying at the point where I try to call this parse if xbar function, the compiler hasn't seen it yet. So I think for this case, I can just move this parse if xbar function up by 1 so that it would be able to see it. Okay, so it is call to implicitly deleted copy constructor of unique. Did I? Did I write this wrong? Let me double check it with their code here. The error is about line 333, which is here. I'm not sure what the problem is. I thought that I'm gonna try to just copy their code, but just in case I made a mistake, because I don't really have a clue about what the problem is. Same problem. So it wasn't my code that was the problem. It could be that it's because, wait. Redo? Okay. It could be that it's because I haven't finished the code, and the next part that we would do is just implementing the code gen method of the if xbar AST node. So I could test that hypothesis really quick and say, hey, if I just implement the code gen method, let me just look at their code. If it did work, this paragraph is saying once we get it working, the LLVM code is gonna look like this. Oh, this actually tells you if you put this LLVM code into a file, call it t.ll, we can use this LLVM-as, which AS I think stands for assemble. Oh, and then you can analyze this. Very interesting. Okay, so that is very interesting. Actually, I want to dig into this a little bit. And I'll sort of abandon my hunt in trying to fix this error message for now. We'll eventually get this fixed, but I think we've completed building out the parser. We haven't been able to test it yet, unfortunately, but I'll stop this episode here, and then in the next episode, we'll look into this LLVM code here for the if statement and see how it works and what it looks like.